Okay, so we're looking at a small part of the topic called Pascal's Triangle, and you may have come across this before when you were expanding out brackets in algebra. But anyway, so Pascal's Triangle is a beautiful pattern that was discovered by a guy called Blaise Pascal, and you might have seen this as the triangle. So we start with 1 and then 1 and 1, 1, 2, 1, 1, 3, 3, 1. And these are actually coefficients that we can use for expanding out brackets. But we've also got now another way of expressing it using combinations. And the first one is 0C0, 1C0, 1C1. So it starts off whatever line it is with the number on the top, and then it goes 0, 1, 2 to generate the numbers. And in terms of the pattern, any number in the pattern can be found by adding the 2 directly above it. So 1s go down the sides, and then 1 plus 2 is 3, 2 plus 1 is 3, etc. Okay, so that's the pattern. Okay, so copy that down and come across when you're ready. Okay, there's another part of Pascal's rule, which is, again, may not be useful, but this NCR is also equal to 1 less than n on the top, and then we're adding r and r minus 1. And where r is between 1 and n. So this number here has to be less than n and has to be at least equal to 1 as well. And how you might use it in a question, if you're given 17C2 and 17C3 and you have to find 18C3, well, 18C3 is the subject, so we take 1 off and 3 goes there, and 1 less than 3 is 2. So if we've got 17C2 and 17C3, then 18C3 will just be the addition of those two numbers. Again, not necessarily useful, but it's a Pascal's rule. Okay, copy that and come across when you're ready. Okay, so we're looking how to generate Pascal's triangle without actually generating the whole triangle. Okay, so for instance, write down the 6th line of Pascal's triangle. Well, we know that 6 will be the top number, and it starts off with 1, starts off with 0, and then it just keeps progressing until you get to the same number top and bottom. So you don't have to actually build up the triangle, you can actually generate the numbers using your NCR button on your calculator. And to calculate 6C3, you're just going to use your button on your calculator. Okay, NCR, okay? So that's how you would generate it without generating the whole triangle above it. So copy that and come across. Okay, so this is, again, just some interesting questions that you can get subsets of a set. So subsets mean part of a set. So here's an example. You have 5 books that you no longer need and you don't want, and how many selections are possible? Okay, so you know the books can be taken. You can take none of them, 1 of them, 2 of them, 3 of them, 4 of them, or 5 of them. Okay, so you don't have to take any, or you could take all 5. Well, that's just an application of Pascal's triangle on the 5th line. So you just add those numbers up. Now this is really one of the great patterns. Okay, so this number 32 can be found because any number, sorry, the sum of all the numbers in Pascal triangle is always equal to 2 to the n. So if we had the 5th line, then the sum of the numbers in the 5th line must add to 32. Okay. Another approach. This is another solution. If we've got 5 books, there's another way of saying it. There's two things that can happen. You can either accept it or reject it. So the first book can be accepted or rejected. So 2 ways. The second book, the third book, the 4th book, and the 5th book. So there's 32 ways that it can happen. That's just backing it up. But this idea that the sum of the numbers in each row equals 2 to the power of n is also very, very, very useful. Okay, copy that and come across. Okay, so we're up to the last page. Again, these are just sort of tricky questions that you can get in Pascal's triangle. So your friend offers you any of the 6 books that she no longer wants, and how many selections are possible, assuming that you take at least 1 book. Now, in the previous one, the option of taking no books is an option. So the easiest way of doing it is to, again, think of all the possible ways that you can take it and then subtract the one way of taking no books. Okay, so what we're doing is we're subtracting 6C0 because you have to take at least least one book. Okay, so that's the quickest way of doing it. And then in part B, how many subsets of 1 to 10 have at least 2 elements? Well, 2 to the 10 would be all the possible ways of doing it, and then we've got to have at least 2. So that means you can't take 0 and 1, and that's you taking 0, and that's you taking 1. Okay, so the short way would be to think of everything that could happen and then just subtract the things that can't happen, and that's the quicker way of doing it. Okay, thanks very much. Bye.